Yeah, so record has been started. Yeah, so today I'm going to explain process and memory architecture. How exactly, like the architecture will going to, designed in PostgreSQL. And when we started the database server, so what are all the process, how the background process will going to work? Okay, today I'm going to explain very clearly. Okay, so see here. So when comes to architectural summary, right? The PostgreSQL uses a process. Okay, so you guys know, right? So in the Sybase or SQL Server, whether the this Sybase and SQL Server act as a threaded or kernel mode, guys. The Sybase or SQL or DBMS or act as a kernel mode or threaded mode. Do you know, guys? Anybody have any idea? Whether
Yes.
Yeah. Uh-huh.
So
Hello.
we have kernel mode and threaded mode, yeah, inside this.
Yeah. So, but normally, yeah. So, see, yeah. But normally by default, which mode will come. So when we started the database server in Sybase, so whenever we are going to start the database server in Sybase, which mode it will come? Like uh I think it's a kernel mode, right?
We
Yes,
have
Manoj.
as well.
Sorry, come again.
Can you ask question again?
Yeah, so see here, whenever we are going to start the database server, at the time it will going to act as a kernel mode or threaded mode in Sybase.
Kernel
It
mode
should
only.
be kernel only. Yeah, we
Yeah,
have to change to yeah threaded.
yeah, yeah, exactly. So, but yeah, see here. So whenever we are going to, what is the difference between kernel mode and threaded mode? Anybody have any idea about this? What is the difference between kernel mode and threaded mode? Anybody have any idea about this? Okay. See here, what is the difference between kernel mode and threaded mode, no? So whenever we are going to start the database server at the time, okay. So each and every connection, it will going to act as a process. Okay. Whenever we are going to start the database server, after the start the database server, when somebody is going to connect it to the particular database server, right? Okay, at that time, in the operating system level, it will going to create a process. So for this thing, we are going to call it as process mode. Okay, so we are going to call it as process mode. Okay, so but PostgreSQL and Oracle, it is a process mode. Each and every connection and each and every transaction, it will going to act as a processes. Okay. PostgreSQL uses a processes and process acts as a supervisor. So I told you, right? What is the supervisor process? CEO. So whenever we are going to start the database server, so at that time, the main process, it will going to start. This process, we are going to call it as supervisor process. Supervisor process means this is the main process. We're able to see, right? This one we are going to call it as supervisor process or postmaster process. Okay, Remaining process, we are going to call it as, okay, so utility processes. The remaining process, we are going to call it as utility processes. Okay, if this main process, it will going to start at the time, remaining utility process also it will going to start. If the main process is going to stop, the remaining process also it will going to stop. Okay, all this utility process is completely depends on the main process. Okay, what are all those utility process? How exactly this utility process will going to work? Today I'm going to explain. Okay, and also see here, when I comes to in the pictorial representation, right? See here PG writer is there, right? See here in the database server as well, in the supervisor below processes, see here BG writer, background writer is there. See here. And also whenever you're going to see checkpoint or stats collector, archiver, auto vacuum, right? See here, everything is there. Auto vacuum, wall writer, archiver, stats collector, logical replication. See here, all the things is there. Okay, these are the utility processes. I told you, right? So whenever somebody is going to connect uh, to the database server, that is also it is act as a processes in the operating system level. See here, the name Richard is connected to the MDB database. Okay, in the operating system also it is created a process. See here, it is created as a process. Whatever we are going to do the transaction, that is also it will going to create as a process in the operating system level. That's why we are going to call it as Postgres is a process mode. Okay. Each and every process it will going to create in the operating system level. Got it? Okay. So that's why we are going to call it as process mode. Okay. See here, guys. Now, how exactly this architecture will going to work? Okay. I'm going to explain now in the paint. See here, this is the complete architecture. This is, if you guys are seeing right, this is the Postgres is the supervisor process. See here, this tab, this is the supervisor process. Okay, whenever we are going to start the database server, see here, whenever we are going to start the database server, right? At that time, see here, this complete architecture will come. Okay. So what the things which will come whenever we are going to start first, the supervisor process, it will going to start. And for that database server, it will going to allocate the memory as well. Shared memory, it will going to allocate. And also it will in supervisor process, once it started, the remaining utility process also it will going to start. Right. And also see here, these are all the devices, permanent devices. So this is the data file and this is the wall segments. This is the archived wall. Okay, so this is the data file. Okay, this is the data file and this is the wall segments and this is the archived wall and error log files. Okay, now I will tell you exactly. But whenever we are going to start the database server, at the time this complete data directory it will going to create. Correct, right? Whenever we are going to initialize, at the time all the things it will going to allocate for the particular database server. Okay, now what I'm going to do, whenever we are going to insert some records into that database server, I'm inserting some records to T1 table. Okay, around 1 lakh records. Okay, I'm inserting 1 lakh records into the database server, means into the database. Okay, how exactly it will going to work, whenever we are going to insert the 1 lakh record, data will comes to shared buffer. Okay, the 1 lakh data will comes to shared buffer. Okay, and also see here the 1 lakh transactional information will comes to wall buffers. Okay, the transactional information will comes to the transaction will comes to wall buffers, but the data will comes to shared buffer, both committed and uncommitted data. Here also in wall buffers, both committed and uncommitted transaction will be there. Okay, in process array, what it will going to maintain, it will going to maintain all the process information in the array format. Okay, this is also in memory. The process array will going to maintain all the process in the array format. It will going to maintain all the process information. Okay, what is there in the shared buffer? In shared buffer, both committed and uncommitted data, and wall buffers, committed and uncommitted transaction. When it will going to write to the disk and when it will going to write to the transactional disk. This is, we are going to call it as wall segment. Wall segment is nothing but this is a permanent transaction device. This is the permanent data file. Okay, this is archived wall. Whenever we are going to do the point in time or whenever something is happened on the primary side, at that time we need archive, right? Okay, without archive, we can't recover the point in time recovery. So that's why PostgreSQL, they are going to provide the feature called archived wall. Okay, when the data will going to write to the data file and when the transaction will going to write to the wall segments. When it will going to write, see here guys, listen carefully now. Okay, see here, there is a, BG writer is there, correct? So there is the utility called BG writer. Okay, this BG writer, it will going to trigger every 200 milliseconds. Every 200 milliseconds. Okay, the database server, it will going to trigger every 200 milliseconds. At that time, what it will going to happen, the BG writer, it will going to call shared buffer and all the committed and uncommitted data will going to write into the data file. Both, listen carefully, this is very important. Both the committed and uncommitted data, it will going to write into the data file. Okay. So BG writer, it will going to write both committed and uncommitted data into the data file. Just a moment, guys. Yeah. So see here, the BG writer, it will going to write both committed and uncommitted data. Okay. And also see here, the wall writer also, it will going to trigger every 200 millisecond. The database server, okay, it will going to trigger wall writer every 200 millisecond. At that time, so when the wall writer, it will going to trigger, right? At that time, it will going to write only the committed transaction into the wall segments. Only the committed transaction, not uncommitted transaction. It will going to write only the committed transaction into the wall segments. Okay, only the committed transaction. Committed transaction into the wall segment. Okay. Anybody have any doubts here up to here? Guys, anybody have any doubts here?
Yeah, Manoj, when you are saying that the insert will happen into shared buffers, right? I mean,
Uh-huh.
transaction will happen uh, in the wall buffers, right? So that means initially entire transaction will happen, then commit will go to data. I mean the shared, I mean the data file, or directly it will go into shared buffer. I mean there is a confusion in the place.
No. See here, a simple thing. Okay. So whenever we are going to insert some records at the time, okay. So the complete insert, whatever we are going to do uh, the transaction we are going to do, right? So those transaction dirty pages committed and uncommitted. Here, do you know the dirty pages, right? So those dirty pages committed and uncommitted data will going to write into the data file. When the PG writer, it will going to trigger at the time, those in dirty pages, both committed and uncommitted data will be there, right? Those committed and uncommitted data, it will going to write into the data file. But as of now, the data file is not consistent, correct? Because in the data file, both committed and uncommitted data is there, correct? So as of now, the data file is completely inconsistent as of now. Okay, when it will going to consistent, I will tell you. But this is the scenario. So when comes to once insert is, whenever we are going to do the insert, the first thing is it will comes to shared buffer. Okay, so when once comes to shared buffer, those dirty pages will going to write into the data file. Okay, now you got it or not?
Yeah, this one.
Yeah. So now, okay. So now in the data file, both committed and uncommitted data is there. But in while segments, only the committed transaction is there. Okay. Now how it will going to consistent for data file. Okay. When it will going to consistent, you know, when the checkpointer triggers. Okay. By default, the checkpointer will going to trigger for every 5 minutes in PostgreSQL. But this is not a recommended. Okay, so we need to decrease the time. Okay, for like for seconds or milliseconds we need to decrease. But by default, the checkpoint timing is 5 minutes. Okay, when the checkpoint it will going to trigger, right? At that time, the checkpointer will going to check the wall segment. What are all those committed transaction it will be there in the wall segment, right? It will going to keep only those data, remaining data it will going to roll back. Okay, it will going to flush out. Okay, based on the complete wall segment, whatever the things is there in the wall segment, only the committed transaction. So based on those committed transaction, it will going to keep only those committed data in the data file. The remaining uncommitted things it will going to flush out. Anybody have any doubts here? Guys, anybody have any doubts here? Vishnu, Srinivas, Vikas.
Yeah, just for time.
Yeah.
Just review the just over.
Uh-huh. Come again. Sorry.
Can you quickly overview again? Okay, that
Yeah. I
what are
will
the
once again I will overview. But see here. So first, this is the main three steps. Okay, this three step you guys are understood a little bit at least.
Yes, Manoj, understood.
Yeah, okay. Yeah, again, I'm going to explain. Once again, I'm going to explain entire architecture, but this 3 steps is very important. So that's why I asked you guys. Okay. It's okay. No problem. Yeah. See here. Now, BJ writer is happened. Wall writer is happened. Checkpointer is happened. Okay. So the next thing is, okay, not log writer, archiver. What is this archiver utility? Okay. Whenever we are going to enable the archive mode, at that time, this utility will going to trigger. Okay. When it will going to trigger, whenever in the wall segment, if the transaction file is 16 MB is full, okay, at that time, that 16 MB file, it will going to copy into the archived wall. Okay, those 16 MB file, it will going to copy to the archived wall. Okay, so archiver, when it will going to trigger, if the transaction file 16 MB file is full, okay, at that time, those 16 MB file, it will going to copy into the archived wall location. Okay, that is the archiver utility. It will going to work like that. Okay, and also log writer. Log writer is completely nothing but error log writer. If in case anything, if we faced any errors, warnings, fatals, all the things, right, in the database level, all the things it will going to write into the error log file. The log writer utility, it will going to write all the things into the error log file. Okay, and also stats collector. What is stats collector? So yesterday I showed you. Okay, when something is changed on the table, if the 10% of the data got changed, okay, at that time automatically, okay, analyze will going to happen, means it will going to update the statistics. This utility will going to check the, okay, table. If the table data got changed 10%, okay, at that time those table statistics it will going to update. Okay, this is the utility stats collector. Okay, and one more utility called auto vacuum. Okay, this auto vacuum, what this utility will going to do, So, yesterday I showed you if the auto vacuum is enabled on the database server at that time, okay, it will going to check the fragmentation and loads. Okay, so if any fragmentation or dead tuples is there on the particular table, it will going to clear the fragmentation, okay, or dead tuples in the particular table. Okay, so auto vacuum utility will going to do and it clear the fragmentation or dead tuples. Okay, so this is the complete architecture. This is how exactly it will going to work. At least a little bit you guys are understood or still not yet?
Understanding, Manoj.
Yeah, I got it. This, what is this fragmentation? You said the vacuum will, auto vacuum will involve when the fragmentation happen, right?
Exactly. So see here, I show you. By default, see here, when we go to the config file, instance one, sorry. Auto vacuum. See here, by default, auto vacuum is enabled in every database server. What it will going to do, it will going to clear, okay, all the fragmentation on the particular tables. Okay, see here, if the auto vacuum threshold is 50, means if the 50 data tuples is there on the particular table at the time, this auto vacuum will going to trigger. Okay, auto vacuum utility will going to trigger and it will going to clear the fragmentation or dead tuples. Got it? Okay, so using this, by default, this utility is enabled. Sorry, this configuration parameter is enabled. Okay, so that's why if this configuration parameter is enabled, okay, that utility also it will going to trigger for every 1 minute. Okay, auto vacuum utility is going to trigger for every 1 minute. Got it? Okay. So now again, I'm going to explain once again. Okay. So from starting to end. Okay. So just please listen again. See here, guys. Whenever we are going to start the database server, at the time, this complete, this process and memory architecture will going to create in the data directory, right? So see here, this is the supervisor process. And so this is the memory for the particular database server. And this is the utility processes. And this is the data file. And this is the wall segment. And this is archived wall and error log. Okay, when you guys are going to initialize and start the database server, this all the whatever I showed this image, right? Everything is created in your data directory. Okay, now if you guys do some transaction like insert some 1 lakh records to T1 table. At the time, the data will comes to shared buffer and the transactions will comes to wall buffers. Both committed and uncommitted data and here committed and uncommitted transactions. Okay. When it will going to write to the data file. See here guys, BG writer. Every 200 milliseconds, the BG writer, it will going to trigger every 200 milliseconds. At that time, it will going to call shared buffers. All the 30 pages, it will going to write into the data file. In 30 pages, what is there? Committed and uncommitted. Both the data will be there. Okay. The BG writer, it will going to write into the data file. Okay. And also wall writer. Wall writer also every 200 millisecond the database server will going to trigger. At that time, the wall writer will going to write all the committed transaction into the wall segments. Okay, all the committed transaction it will going to write into the wall segments. Okay, and also when the data file got, so it will going to consistent. When it will going to consistent, when the check pointer, it will going to trigger for every 5 minutes by default. At that time, the check pointer, it will going to check the wall segments. Okay, whatever the committed transaction is there in the wall segment, based on that, it will going to keep those data, committed data in the data file and remaining data, it will going to flush out. Okay, and also, the next thing is, okay, so log writer. The log writer is completely write all the errors, warnings, fatals things into the error log files. And archiver. What is the archiver? Archiver, whenever we are going to enable the archive mode, at that time, the archiver utility, it will going to copy every 16 MB transaction file into the archived wall location. And stats collector. What is stats collector? Okay, if the 10% of the data got changed in the table, okay, the stats collector, it will going to update the statistics for those tables. And So auto vacuum. Auto vacuum, what it will going to it will going to do? It will going to clear the fragmentation or dead tuples. Okay, if the 50 rows is there in the particular table, right? 50 dead tuples is there in the particular row, right? Sorry, particular table. Those things it will going to clear in the particular tables. Okay, this auto vacuum completely works on based on the configuration values in the configuration file. Just now I showed you, right? Okay, so based on the parameter value, it will going to work. Okay, this is the complete scenario for the process and memory architecture. Anybody have any doubt here?
Manoj, auto vacuum after where it will flush these fragmentations and all? In data file, all the segments, or only in data file?
In data file. In data file.
Okay.
Yeah.
What about wall segments and archived wall? Is there any?
No, in wall segment, only the transaction will be there. Only the committed transaction will be there. There is no link. You were talking about auto vacuum?
Yes, yes. Auto vacuum for archival. See, suppose if some deletions happen, it has to flush out from archived
No, no,
wall
no, no,
also,
no,
right?
no, no. This is not that archival. This is completely a transactional archival. This is completely a wall and archive wall. This is completely transactional, transactional file. Okay, this is the auto vacuum will not going to touch those things. So it will going to touch only the consistency for data file. So we need to check only the consistency in data file only, right? Not log files, right? So that's why whenever we are auto vacuum will going to happen at that time, it will going to check only the data file. Got it?
Yeah. Okay. Thank
you. Yeah. Anybody others? Anybody have any doubts here? Anybody have any doubts? This is very, very important, guys. Yeah.
And auto vacuum, what is the recommended value? How many minutes is the recommended?
Yes, see here, auto vacuum normally, auto vacuum is not recommended for production servers. Okay, so we need to disable the auto vacuum normally in every production environment. So so the recommended is we need to disable for that one. Okay, so better auto when we are going to do the vacuum, so in every weekend we need to schedule for every weekend or non-business hours. Normally, in all production database servers, we are not recommended for auto vacuum. So we need to schedule for weekend or non-business hours. Whenever we are going to, do the auto vacuum in business hours, lot of IO performance issues will come. Okay, so that's why we are not recommended to enable the auto vacuum in business hours.
Okay, thank you, Manoj.
Yeah. Others, anybody have any doubts? Because I'm asking too many terms because this is very, very important, guys. Okay. If you have any doubts, I'm going to explain one more time. Okay. Can I explain one more time?
Can you tell me about the archive wall? I mean, this is something related to the transaction log file kind of thing. The archived wall.
Exactly. I will show you in practical only. See here. Here, where the transaction file will be there in the database data directory, where the transaction files will be there. Guys, in which folder? Guys, where the transaction file will be there? I'm in the instance 1 data directory. Where the transaction file? In which folder it will be there? Guys?
Log files?
No, log file in log file only error log will be there. But just remember
Home
where the
directory.
transaction, yeah, transaction log. Transaction log is nothing but just remember every time write ahead log, correct? So in PG underscore wall, right? PG underscore wall. See here, guys? See here? This is the file, right? So these are all our transaction files only. See here? Every transaction file, it is going to create 16 MB. See here? 16 MB. See here? Each and every transaction file it will going. Once the 16 MB is going to full, it will going to create one more 16 MB file. Okay, these are all our transactional files. Okay, when it will going to write into the archive means archive path, once this 16 MB is full, okay, the archiver utility process, it will going to copy into the archive directory. As of now, if you're going to see this archive mode, right? pi postgresql.conf, see here, archive mode. See here, as of now, archive mode is off. Okay, that's why the archiver utility, it will not going to copy to the all the transaction files. Okay, whenever we are going to enable this archive mode, at the time we need to specify the path as well. Archive path as well we need to specify here. Okay, at the time, okay, archiver utility, it will going to copy those 16 MB files into the archive location. That's all. Archive location, why we are going to maintain the archive location, just for safer side. If something is happened, something disaster is happened on the database server, we can easily recover the things from the archive logs. Archive logs. Okay, this is the main advantage for archive logs. This is completely a transaction log only, but for the safer side, we are going to maintain in the different location. That's all. Okay. I think I hope you got it right, Pradeep.
Yeah, Manoj, I got it. I mean, it's just similar to the transactions or in Oracle also there will be archive access, right? The backup will happen every 15 minutes or 5 minutes. The same kind of thing. This is also.
Exactly. Okay. Anybody have any doubts? And also see here, I told you, right? Checkpoint timings. Check the checkpoint timings here. See here, the checkpoint timeout is 5 minutes. See here, guys. The checkpoint time is 5 minutes. Okay. The range is we can set for 30 seconds to 1 day. Okay. By default, it will come at 5 minutes. Okay. But this is not a recommended. Okay. This is not a recommended one. So this is completely where the transaction files will be stored. Guys, please remember under PG underscore wall folder. Okay, all the transaction files will be there on PG underscore wall. Where the error log files will be there? The error log file will be there in log directory. So this is the one. This is the error log files. This is the transactional files. Okay, this is the transactional files. This is the error log files. Okay, I hope you guys are understood, right?
Manoj, all transaction files will be in data file, right?
Sorry, come again.
All transaction files will be in data file.
Don't mention that as a data file in data directory.
In data directory.
Yeah. So data file is different, data directory is different. Okay. All the transaction files are available in data directory for the specified database server. Okay. I think I hope all are understood. Can I proceed for next thing?
Only one doubt, Manoj. So this
Yes, yes.
archival logs and active logs, whatever, all are common for entire cluster, right? And
Exactly.
so there
Entire
is no,
cluster.
it's not difference between database to database. We don't have any difference.
No,
Everything
no.
in stored under the instance only.
Exactly, exactly.
Okay.
There is no difference. There is no difference. But so why here we are going to separate the archive, when something is happened in the primary side, at least we need to maintain the archive in separate machine. Okay. If sudden disaster happens, at least we can recover the things from the archive. So that's why we are maintaining the archive logs in the PostgreSQL. We can easily recover the things from the archives. But archive is nothing but completely transaction logs. Okay. I think you guys are got it right. I think I hope all are understood. Okay. Yeah, so this is the complete architecture for PostgreSQL.
One doubt, Manoj. See,
Yes, yes.
we have multiple databases under the single cluster. If one database is corrupted, right, we cannot, can we restore from these active logs or archive logs only the single database? Because see, all the database logs are going to the same log file.
Exactly.
So while
Exactly.
recovering also, it will,
That is not possible.
that is not possible.
No.
Okay.
We need to recover entire cluster. We
Oh,
can't recover the single one. So yeah, that is the one. Exactly. You are right. Okay. So whenever
So
we are,
if I
yeah, yeah,
sorry, so
yeah.
if an instance there are 10 databases, means we can't recover the 10 databases. We have to restore the instance itself. We are saying.
Yes, we need to restore the complete instance.
Manoj, this Santosh here.
Mhm.
Manoj, if for example 100 GB of data, I mean database server is there. So in that case, we should recover 100 GB of database instance parallelly, right? So wouldn't be a drawback for storage, because if we don't have sufficient storage, so we want to restore only particular database, and that database is around 1 GB or 2 GB. For that 1 GB or 2 GB database, we are actually required to restore whole instance. So do we have
Yeah.
any alternative,
Yes,
or
yes. See, the thing
limited?
is, yeah. I got your questions, but the thing is, okay, uh, there is a point in time recovery is there, but apart from that, we can't restore. Yeah, the one thing is possible. Okay, so we can do the one-to-one database recovery. That is possible. So so I'm talking about only the transactions, but we can do one-to-one restoration is possible. That is possible. But the thing is, we can't recover the complete, so single database using the particular transaction log. That is not possible. But we can restore the things from one-to-one database. That is possible. Using the complete PG, there is a, like a PG dump is there. Okay. And PG restore is there. We can do the restoration using those
PG,
things.
yeah, PG dump and PG restore is like a something is like a backup and restore only, right?
Exactly, backup and restore. But using this transaction log, we can't do the single database restoration. That is
Oh,
not possible.
okay.
Exactly. Yeah. I think I hope you understood, right, Santosh?
Yes, 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 Manoj.
Yeah. Yeah. Okay. Yeah. So this is the complete overview of process and memory architecture. Okay. So, like this is the complete theory. Whatever I explained the things, right? So this is completely one line sentence for each and every utility processes. Okay. This is each and everything is one line things. Okay. See here, the background writer writes update the data blocks to disk. So whatever I told, the same thing. It will going to write all the committed and uncommitted data blocks to the data disk. Wall writer flushes write ahead log to the disk. Means it will going to it will going to flush only the committed transaction into the disk. And checkpointer automatically performs a checkpoint based on the configuration parameter. I told you, right? Every 5 minutes it will going to run. And auto vacuum launcher starts auto vacuum workers as needed. So based on this is also configuration parameter. Okay.
Yeah.
Yeah. Yeah. Santosh, you have any doubt?
Yes, yes. Can you
Yeah.
please
Yeah. Please tell me.
differentiate uncommitted or committed transaction versus dead tuples?
Okay. Dead tuples. Yeah. Dead tuples is nothing but see here. Whenever, yeah, I will show you in the paint only. Okay. Example. So here, okay. So yeah. See here, guys. See Santosh. Here, I'm going to insert 10,000 records here. Okay. I'm going to insert 10,000 records here. So this is completely one table. So here I'm going to insert 10,000. Here also I'm going to insert 10,000. 10,000. Okay. So now if I am going to delete, okay, I'm going to delete this one. This 10,000 I'm going to delete. Example. Okay, I'm going to delete this 10,000 records. At the time, once the 10,000 records is deleted, right? Okay, just logically it will going to delete. But physically, this space is not going to reclaim this space to the operating system. Okay, this is not going to reclaim to the operating system. This space is completely consumed to particular table only still. Okay, this space is there, right? Whatever the space is acquired previously for this 10,000 rows, right?
Okay.
So this space we are going to call it as dead tuples. Okay, we are going to call it as dead tuples. Okay, again, if you're going to, you know, uh, delete some more records here, right? At the time, again, if you are going to delete, right? At that time, this is also logically it is going to delete, but it is not going to reclaim to the operating system. At that time, how many dead tuples is there now? So 20,000 is the dead tuples. The complete dead tuples for this table is total is 20,000. Okay, this is we are going to call it as dead tuples. Got it, Santosh?
Yeah, Manoj.
Okay, this is how the dead tuples will going to generate. Okay, and also see here. Example, again in this scenario, only for delete it will not going to generate the dead tuples. Okay, whenever we are going to happen update, right? At that time also the dead tuples will going to generate. You know how that whenever we are going to do the update at that time how the dead tuples will going to generate? Do you know how, Santosh? Because whenever we are going to do the update at that time it will going to delete and insert. It will going to delete the records and it will going to insert, right? So that's why at that time the dead tuples it will going to generate for the particular table. If I am going to update now, right? Like instead of 10,000, if I am going to update some 20,000 like that, right? At that time, the total number of dead tuples is 30,000. Okay. This is how exactly we are going to call it as dead tuples. I hope you understood, right, Santosh?
Yes, Manoj.
Okay, when this dead tuples it will going to clear. Okay, whenever we are going to do vacuum, right? Vacuum. Okay, at that time, this dead tuples it will going to clear. Example, whenever we are going to do the vacuum for the particular table, right? At that time, okay, it will going to clear all the dead tuples. And it will going to reclaim this space to the operating system. Okay, whenever we are going to do the vacuum, at that time, it will going to clear the dead tuples and it will going to reclaim this space to the operating system. Okay, that's why we need to do proper vacuum for the complete database or the particular tables. Okay, vacuum is very, very important. Okay.
Here
So
we
this
are call it as
vacuum, we
vacuum.
need
Another
to.
terminology we are calling as reorg, right? That's it.
Exactly. True.
Yeah.
Exactly. Reorg. Yeah. Exactly true. So
So
in
this
reorg,
vacuum, we
many
have to
types is
schedule it,
there.
Manoj?
Yeah. Come again.
Sorry, no, this vacuum we have to schedule it, or I mean, by default it will run. Or how to? I mean, whenever
Yeah,
we
yeah.
do any
There are two things
DML
is there.
transaction.
Yeah. There are two things is there. First thing is we can also automate the vacuum using the auto vacuum. That is also possible. And also we need to schedule this vacuum, so for based on our business requirement. Okay, whether in weekend or whether in non-business hours, we need to schedule. Okay. So, like I'm going to explain those things in maintenance module will come, right? At that time, I'm going to explain very clearly. Okay. So just please remember, vacuum is nothing but completely reorg. Okay. It will going to clear the fragmentation and reorg also many types. So reorg compact, reorg reclaim, something is there, right? So same way in single vacuum, it is all the things are possible. Using this single command, all the things are possible. Okay. Yeah. Pradeep, you understood, right?
Yeah, got it.
Yeah. Okay. So this is the complete architecture. Okay. So tomorrow let's explain some other things. Okay. I don't want to explain only theory. So if I'm going to explain theory, you guys also getting bored. Okay. So tomorrow I'm going to explain more theory and practical both. Okay. So we'll meet in tomorrow and try to, listen this video once again. If you have any doubts, please let me know. Okay. I'm going to explain one more time. Okay, guys. Yeah. I'm going to stop recording.